All right, I think it is time again to talk Commander Banban, Iceberg, and other cool Trino things in our Trino meetup, hosted again by Starburst. So you can find us at TrinoDB and at Starburst Data on GitHub. Also, of course, on TrinoDB/Trino. Today, I'm very pleased to announce that Ryan Blue is joining us. He's the creator of the Apache Iceberg project, and he is currently at Netflix, busy engaging on a lot of interesting use cases there. And he's going to tell us more about that today. Myself, I'm Manfred Moser. I'm one of the co-authors of the Press to the Definitive Guide, which now is available as a new edition called Trino, the Definitive Guide. And I'm a regular contributor to Trino, specifically around the documentation. So what are we going to do today? Today we're going to go through a bit of an overview of Trino again, just for those of you that don't know enough about Trino yet and just want to have a sort of high level understanding. I'll have a couple of announcements around the community, a t-shirt giveaway, and Trino the Definitive Guide giveaway. All of this is not going to take us too long, and then we'll hand over to Ryan to tell us more about Apache Iceberg. As you see, this is going to be a table format for data lakes with very many unforeseen use cases. We talked about this in the past already in our Trino community broadcast with Ryan, myself, and Brian, and there was just way too many interesting things to talk about. So today we're going to learn even more from Ryan, and we will round this out with a Ask Us Anything section where you can ask us questions. Those questions that you have, please let us know what you want to know. We will sort of gather questions on the GoToWebinar chat. We'll also use the questions feature that's available here, so feel free to chime in on those. And of course, also, if you want, you can use the Trino community broadcast channel on the Trino Slack instance, or just Twitter at TrinoDB. We'll keep an eye on that. Of course, the easiest will probably be just to use the questions within GoToWebinar. So Trino meetup today. So what is Trino? Quick. Trino, as you know, if go super high level, you talk about Trino. It's a fast distributed SQL query engine designed to query large data sets distributed over many data sources. Now that's all fancy talk, but what does this mean? Well, it means that you can connect Trino to all sorts of data sources. And you see here on the right, Iceberg is a very prominent one, but there's many others. Originally, it was all about querying Hive and Hadoop sort of storage systems. But the connector architecture of Trino enables you to query all sorts of relational databases like Postgres or MySQL, but also any other storage system that you can write a connector for and express the data in there in a table format. So things like streams in Kafka or NoSQL database, MongoDB, or Elasticsearch documents, and all sorts of things like that. All of those can be connected to the Trino cluster. The Trino cluster is a cluster of many machines, typically one what's called the coordinator, and then many workers. And they all work together to figure out what queries to run and how. There's a bunch of internal APIs, there's parsing and analyzing and stuff like that happening. But ultimately what matters is that the Trino clients, any tool that you can connect to Trino, such as dbeaver or Looker or Apache Superset, Power BI, many others, they can connect to Trino. They essentially connect to the Trino coordinator and submit queries there, either by you clicking in the UI to change a filter on a dashboard or something like that, or like handwriting SQL queries. And then Trino processes those by analyzing it, planning how to execute it, and then the many workers in the cluster, typically anywhere from, 10 to 1,000 workers, parallel process those queries. And that allows you to write queries that access a lot of data in a lot of different data sources, and therefore gain a lot of understanding of what's going on with all the things that produce that data. And that can be whatever, right? So that's the super high level understanding of what Trino is. So where does Trino sit? Well, originally, this is a cool little map. If you see here, there's the different sizes of and lengths of different data. Here you see the Hadoop region, Lake FS, and then Kingdom of Analytics, log, structured data. Trino really fits everywhere because, as you saw here, as long as the data can be expressed in a table format with like rows and columns and data into certain data types, Trino can query them. And so all we need to have a map of sort of how these aspects of the underlying data source are translated over to the Trino concepts. And Trino can work with many of those. Typically, the focus on Trino is OLAP, so online analytical processing, where you basically do read access to the data. So you read the data out and do analytics on it. It's not so much into OLTP, which is online transaction processing, where like financials or transactions go in. So there's a lot of writes. Trino is more optimized on reading data, so OLAP. And it can read other data sources like documents, key value, graph databases, and so on. Now, where is Trino coming from? Just quickly, because Trino is or used to be known under the name Presto. It was founded in 2012 at Facebook by a bunch of founders who are all now with Starburst, our venerable sponsor for this meetup today. At some stage, the Facebook management wanted to change the committership rules and around it. So in 2018, the founders, Martin, Dane, David, and Eric, all left Facebook and the Presto project and started a separate Presto software foundation, the Presto community, people that write the connectors and like use it in production in all sorts of places by then, pretty much followed along and used what was then called Presto SQL or Presto SQL. However, that then was backtracked in 2019, so we were no longer allowed to use the Presto name. Facebook wanted to continue to use the Presto name, created Presto DB, and worked with the Linux Foundation, and then they basically wanted to keep the name Presto to themselves. So we decided to move on, and now we have Trino. And Trino has been growing tremendously ever since the split in 2018. Our changes accelerated tremendously, and there's lots and lots of changes, all sorts of new features. We have a new release every 2 weeks, and the community is growing all the time, and we have great collaboration with people like Ryan and others at various companies all across the world that use Trino in production. And you can see that also on the Trino.io website, who our users are, or a small subset of them anyway. And that gets me to the community. The Trino community is very big. We have many thousands of users on our Slack channel, so trino.io/Slack. Brian and myself, we run the Trino community broadcast every 2 weeks, where we talk about the latest news and releases, have interviews with people and other things. We run these virtual meetups like today, and you can always contribute to the project. It's open source as well, of course, and we manage it under Apache license, and we have good first issues in our GitHub repository, and we work with many developers all the time. Even if you want to just start writing a blog post or do some documentation, you can find many aspects to there. A very important, great event coming up related to the community is we will run a Arduino Summit in September. So you still have a little bit of while to get your vaccinations up and going and everything. You can also join us virtually, of course. And so on the 15th and 16th of September, we will have a Arduino Summit where you can register, as you could see, on starburst.io/Trino Summit 2021. We will have various training sessions with some of the co-creators and maintainers of Presto. Other contributors and users will present their use cases similar to what Ryan is doing today, but on all sorts of different use cases. And of course, if you want to present, also reach out to us and be part of this event. It will be a great thing to enjoy working with and collaborating with the other members of the Trino community. And of course, we'll also be available to give out some cute Commander Banban swag. Specifically, even today, thanks to Starburst, you can request a Commander Banban shirt like I'm wearing here today. Just go to this URL, starburst.io/info, meetup Trino t-shirt, and we'll send you one ready for you to wear. Another free giveaway from Starburst is the book that we just finished and recently updated. Myself, Matt, and Martin updated it to the Trino naming convention and all the new, Docker images, command line tools, namespaces, and all that stuff. And the book from O'Reilly, Trino Definitive Guide, is now available in this new edition. We also fixed all the errators and did various other updates. And it's available for free. So get a copy from Starburst, starburst.io/info/O'Reilly Trino Guide. You can also find it on the Trino.io website with links there. So Trino.io is where you can find everything related to Trino anyway. But we don't want to just talk Trino today. We have Ryan here who is gonna tell us lots of cool stuff about Iceberg, Apache Iceberg as a table format for data lakes with unforeseen use cases, following up on our Trino community broadcast from recently. So thank you for joining us today, Ryan.
Hey, it's great to be here. Sorry.
That's cool. I will try to figure out how to give you control again.
Control. I actually don't need control since I'm on a Mac. I don't actually have.
Oh, you don't have any slides or anything? You just want to chat?
I don't have my materials.
Okay, that's cool.
I was going to throw up slides of maybe something to refer to, but yeah, since we're on a different computer, I don't really know how to do that anymore. So it's all good. Let's just talk.
Okay, cool.
You want to be on camera or just show my picture? That looks better, to be honest. But
I think it's probably fun to show you as well.
Yeah,
but
let's do. That sounds good. That way you can see me typing on my other computer to register to get my free Trino t-shirt.
Yeah, lots of people will hopefully take advantage of that. All right, yeah. So I will leave the screen shared, I guess, or should I stop?
Oh no, let's just chat and you can show me.
Okay, cool.
Sorry, the two of us, talking.
Yeah, okay, cool. So tell us more about Iceberg at Netflix. What's happening?
All right. Well, so I came up with a big list of just like things that we use it for. And so first of all, I want to throw out there to anyone on this webinar, like if there are things that you're interested in, like something that you've heard us talk about or briefly mentioned in the past, feel free to throw that in the chat and we can talk about that here. I'm happy to talk about any of the use cases that you guys who are here attending want to hear about. That said, there are a few that I think are pretty interesting. So I'll throw out some of those ideas, and if people want to vote for them, go for it. Otherwise, I'll just keep talking because that seems to be what I do. So the first one I've got is updating tables for GDPR. Now, the idea here is that we've got a lot of tables that were designed for efficiency of how we're going to query those tables, and not for being able to, number one, like find user information to be able to provide to people for like external data requests. And number two, we also, never really designed those tables for deletes, which means that in a lot of cases, we are having a lot of trouble going through and deleting those records efficiently. So I can talk about how Iceberg helps us do that as one of the options. Another thing that I think people would probably be interested in is table-to-table streaming. Now, I know that this is not really a Trino use case in the more traditional sense, but I think what's interesting about it is that it allows you to see how different systems can all interact with the same data set. So you can have really fast queries on data that you're actually using between streaming systems as well. So I can talk a little bit about how Iceberg can support those use cases if there's interest. Then there's also our patterns for supporting really selective queries with Trino. This was where we wanted to have, basically 2 seconds to get information about a user's account so that we can help them when they're on the phone. And how we use Iceberg to basically take a large cluster of like keeping all this data in memory and replace it with just S3 and Trino. And then I can also talk about just like general streaming use cases and like lowering the amount of time to go from getting data from Kafka into a table and then into the hands of users with ad hoc queries through Trino. So any of those options sound like...
So it's interesting. So we already got a first question before you even started. So let's talk about that one first. And then there seems to be a lot of interest on the table streaming. Personally, I'm also interested on the whole data hiding and like GDPR compliance. So how about we start with the first like super high level question that Corey has. So he is saying, and I have to sort of like put this in context, the Iceberg connector / Iceberg itself needs metadata about what all the files have, right? Like most of the metadata is in the files, but then you need some sort of metadata to point to those files. And typically that's often used with Trino at least is a Hive Metastore. And that's where his question is. He's saying at Netflix, what are you using as the Metastore with Iceberg? Are you using AWS or with Glue, or have your custom Metastore that is maybe just running Hive Metastore separately somewhere in a Trino in a cluster, or are you doing something else altogether with whatever Metastore?
Yeah, good question. I should mention just how the Metastore interacts with Iceberg, because it's a little different than like Hive tables. So the only thing that the Metastore actually needs to do for Iceberg is keep track of what the current table metadata is, or what the location is. So it's a very lightweight pointer, essentially, from a database and table name to some metadata bundle, or usually metadata location in S3.
So correct me if I'm wrong, but that basically means if you are using a Hive Metastore, it's literally just one table that's being used, and all the other stuff is not used, really, right?
Yeah, exactly. So what used to happen is the Hive Metastore would track hundreds, thousands, or up to like millions of locations for each partition in the table. What we wanted to do was not put all of that load on the Metastore itself, and make it super lightweight. So all of that information is actually stored in Iceberg metadata itself about what the files are, what partitions they belong to, and things like that. That allows us to have a super lightweight Metastore, and then to push all of the planning operations, instead of like taxing a central Metastore with the planning. What we do is we distribute that to all of the clusters and all of the drivers that are planning queries against Iceberg tables. So we actually scale a whole lot better in that case.
Yeah, that's a good. That's interesting because like you were mentioning, like hundreds of thousands of tables on the Hive Metastore. I know from experience with some of our customers and stuff, and also other users in the Trino community, the Hive Metastore can be a performance bottleneck. So it's not just some crazy idea that you came up with, Ryan, to not make this complexity be there, right? Like, did you experience that in the past? That you were having problems with the Hive Metastore?
That's exactly why I bring it up, because what we've done is we took the Hive Metastore and we built a layer on top of that. And we basically rebuilt portions of it, and we have a system called Metacat. Metacat acts like the Hive Metastore, so it exposes a Hive Thrift API, and we can point things directly at it if they want to look exactly like the Hive Metastore. But in the end, we did that in order to be able to scale out that service across 10 or 20 machines in our Amazon infrastructure. So we now have this distributed Metastore system. So it was kind of funny when we added Iceberg support to that. we basically added one very simple thing. So our update table command, it performs this atomic swap. So when you need to commit Iceberg data, you say, I'm taking a table that I think is at this version, and I'm replacing it with this other version. And the Metastore's responsibility is to atomically swap that pointer and ensure a linear history, so that only one writer can perform a swap at the same time, and the other fails. So that was actually really super simple for us to do.
Yeah,
The
that's cool.
is actually going and trying to expose the Hive concepts through that same system, which we're actually delegating now to Trino. So we have like a get partitions API that older things use in order to check basically the state of the table. We don't encourage that anymore, but that was very hard to do on top of this system. And so now we're delegating to a backend Presto, the old name, backend Presto cluster to basically aggregate all of those things and satisfy the user's query for partition metadata.
Okay, very cool. So the Hive Metastore as such will stick around then, but really be like this super lightweight little pointer reference only then, right?
Yeah, and I'm actually pretty excited to see like what this allows us to do. I think there's an open question of how we want to move off of like the Hive Metastore infrastructure, like whether we need the table space to persist. So when we were moving Netflix over to Iceberg tables, we wanted the namespace, the databases and the table names to basically be either Hive or Iceberg, and so that we can flip over a table and now it's Iceberg. Just go and scan the table, figure out all the metadata, build the Iceberg metadata, and then commit it. But I think that there's an open question of whether you need to do that or whether you should just set up an Iceberg Metastore alongside and copy tables between the two. That is a whole lot easier to set up and maintain, and that gives us some really interesting possibilities with the Metastore, where we're not necessarily supporting the old Hive Thrift API and some of those things that are really difficult.
Yeah, and if you expose it in Trino, you could potentially hide all that underlying complexity and just like be like, well, it's the same schema and catalog maybe, right?
Yeah, so the issue there is that it's quite hard to delegate. So if you get a query in, you need to delegate to either the Hive connector or the Iceberg connector in Trino. And that delegation only works, I think, for certain queries right now. And so like the integration is a lot more difficult if you're trying to do it at that level, where you might have to use one connector or another. So it actually fits with Trino a whole lot better to have a separate Metastore for your Iceberg tables.
Okay, and what would that separate Metastore then be in an ideal world? Like, have you seen different implementations of a simpler one?
Yeah, Iceberg doesn't have an opinion here. We think that it's an area where we really want to see new ideas and new techniques, really. There's a JDBC one that I'm reviewing right now in the Iceberg community. Like every large organization has hit the scale problem and has like built their own, which is why it's pluggable in Iceberg. And so like I'm really interested to see what's next after the Hive Metastore in this area.
So when you say JDBC, does this mean it'll be a JDBC connection to whatever that underlying storage is, and you're communicating to a specific table in that via JDBC?
Exactly. So the JDBC one is kind of neat. We just have a table that lists, it's like, database, table name, metadata location. And our queries to basically to load a table, you just go select the database and table and get that metadata location. And in order to commit, we do an update. So update where database is this, table name is this, and metadata location is something. And if you get one row changed, you were successful and you atomically swapped the pointer. If it fails, then you go back and retry. So like it's a super simple table and thing for a traditional like OLTP database to support.
Yeah, so all the relational databases could just be used for that, and lots of companies would have different preferences there, but all of them would have something already and in-house expertise on that, right?
Yeah, I think the tricky thing here is because we are able to distribute the workload so broadly that you might have potentially thousands of clients connecting to the same database, and that could cause some problems. So like if you're trying to scale up, you probably wouldn't want a direct table, but it is a really interesting use case for like a small organization. Go to AWS, set up an RDS instance, use this, and you're basically up and running to have an Iceberg table catalog.
Very interesting. So that's I think that rounds out our Metastore discussion pretty well. So it's a very important aspect of it, but really it's not. It's just this little pointer, and then Iceberg takes care of the rest, which gives you a lot of that power. So maybe should we talk about some of the power in terms of your GDPR use case next, since that's one of the things where you can like mask and do all sorts of stuff.
I would love to. So I think the GDPR use case is a really interesting one. This is not something that we saw ahead of time. I was really quite surprised when it worked, and it kind of confirmed to me that we were onto something with the design.
Do you want to maybe step back a little bit and tell us what that means? Like I know GDPR is the like data privacy and stuff like protection and stuff rules mostly from Europe, and there's similar rules now in California and probably hopefully over the world at some stage. But what are the specifics around GDPR that you needed to look at?
Yeah, so there are two main requirements I think that I'm going to talk about here. One is the ability to provide people their data. And I don't know much about GDPR itself. Like I think everything falls under the general like GDPR bucket. But we have two main requirements. We have to tell people what data we have about them or about their account. And number two, we have to be able to delete that data on request. These are kind of difficult in the big data space because you might have, quite a bit of data by volume, and it's probably mixed together with all sorts of other things. So imagine, you've got a list of all the titles that you've gone to Netflix and watched or rated. By the way,
that's a long list, man.
This is all hypothetical because I don't actually work on that side. I work on the platform side. So like,
I'm sure your list is also long. I'm sure you're watching Netflix too.
Yeah, exactly. Like Netflix knows what you're watching, and we use that to recommend other titles to you. And you do things like rate titles or thumbs up and thumbs down. So that, imagine all of that goes in a table. That's been happening for what? Netflix is now 20 years old. Streaming is like 10 to 15 years old. So, we've got a lot of data that has been sitting there, and really it was laid out for efficiency, right? So we're going to go and say, hey, what was the activity around some time? And most data sets, if you look at companies, they're laid out in terms of time. What did someone do at some time? And then we can see how changes in behavior go over time, what titles were available at that time, and things like that. So we have a lot of data sets that were not built or laid out to focus on a user, right? If you're going and saying, how do I build recommendations off of this data set? We're not ever zooming in on some user and looking at what they're doing. But now we need to say, oh, here are all the things that you rated and when. So the challenge is, how do we get quick access to those without scanning the entire, say, 5 years of data or 10 years of data? And then another challenge is, how do we delete things without rewriting, again, just all sorts of data throughout this table. One area where Iceberg comes in here is that you can change the layout of your table as needed. So we thought that originally when we were building Iceberg, we thought, hey, if we're going to be replacing this low level in our databases, we need to be able to basically fix some of the systemic problems that we've been running into. That's why we fixed like table evolution, or sorry, schema evolution. Another thing that we stole from like database best practices in the 90s is this idea of having a logical and physical separation. So your table is the logical data, right? That's how you think about querying and working with data. But at the end of the day, there's some physical structure, directories and files and partitions and things like that. And what we wanted was to separate those two, because in the old table structures, if you wanted to, for efficiency, you were actually querying the structure of the table. If you wanted to change how your table was laid out, you could not do that without changing all of your queries as well, because your queries were referencing directly the partition columns underneath the table that were formed by the physical structure.
Yeah, that's one thing that I always found amusing when, like, I'm more coming from the relational database side of things, and it was always weird how, like, in order to query like a Hadoop or so, you need to understand all this like underlying stuff and like partitions and buckets and like whatever, optimize your query. When you create your table, you need to have the right order of fields and stuff. If you're coming from an SQL and relational database background, you're like, who cares? Like, I just create the table and like the system takes care of it for me. So Iceberg, it's very interesting that you're saying that Iceberg brings those kind of like best practices back into the world of like object storage and distributed storage. So it's amazing to see that happening, and it's very good.
Yeah, I mean, it's like I said, it's taking things that we were really good at, but we sort of discarded when we started building these databases as distributed systems with the Hadoop era. So we're bringing those concepts back. And what that allows us to do, like I said, is to update the structure of a table. So now what we can do is we say, okay, well, we've been storing all this data by day for 5 years. Well, let's immediately start storing it by day, and then bucket the users, so that we hash the user ID, mod that by 1,000, and now we have 1,000 buckets. So then what we do is every time we query that table, if we're looking for a particular user ID, I only have to search 1,000th of that table instead of the entire thing for that user. And so that really helps us cut down on the costs. And it's only possible without a massive massive re-architecting of our tables, because we can make those changes thanks to Iceberg. And it's the same thing with the deletes as well. We're able to, because we need to know where the data is, what files do we need to rewrite, we can find those things more quickly thanks to Iceberg. And that's another area where sorting your data is very, very helpful. Iceberg can keep track of the min and max values for a column in table metadata, so that even within one of your 1 in 1,000 buckets, you can know which of, say, 10 data files has the range of IDs that you're trying to rewrite.
Cool.
And so that, if you're now, just changing how you write your data to bucket on top of your existing partitioning structure, and then sort the data by that ID, you can get to where you can rewrite individual files in that table, rather than rewriting huge portions of it. And so that is something where I think Iceberg really turns a corner in terms of like what you can do. And again, it doesn't require changing the entire table, although you can like go in the background and start turning your daily partitioned into daily and bucket partitioned table.
Oh, cool. So I just had a thought when you talked about the statistics there. So and that leads me to another question that's also coming up, and it's about the Trino connector for Iceberg. So as you know, the Hive connector that we have supports table statistics, which is about that, like, you know, min max values, distribution of like commonality of null and stuff like that. Is the
Mhm.
Iceberg connector exposing those table statistics it has into Trino for the Trino connector? Because Trino can use those table statistics for optimizing queries with the cost-based optimizer.
So this is where we're actually working with you guys to improve Trino. So the issue is that Iceberg basically wants to plan a query in order to return the statistics. Because you don't really know like how many data files you're going to read, and accurate statistics are based on the data files. So in Spark, for instance, we will just, when you ask for statistics, we'll plan the query, return the statistics, and then return the splits later. But we can't do that in Trino because Trino does something really clever. So what Trino does is it starts processing the query before all of the splits are planned or all of the tasks are planned, which is really great for low latency queries. Say, you know, select, you know, limit 10. You're going to get results back really fast before you're even finished planning that query. But you also want to get stats earlier than that, and you know it would defeat the purpose of that of that process if you got stats by planning the entire query. So what we want to do is introduce you know, some sort of mode or you know, brains into the Iceberg connector here, and possibly have a new API in Trino itself to support this, so that we can say, you know what, take
Just give me
this,
the stats sort of thing.
yeah, like take 100 milliseconds and see how far you can get, but return some estimate after that time.
Okay.
Or you know, I think we've done a couple things where if a table is like itself really small, we have aggregate statistics at the Iceberg metadata level to say, like, we know how large this snapshot is, so we can return that if nothing else. So it's really just an area where we need to improve the, I think, API and connector. And like I said, we've been talking to Starburst about that already.
Yeah, well, we're all on it, and we're all loving the work that's happening. So it's great. So with regards to the connector, there's also a question that came up from Srinivas, and I think it's a bit based on a misunderstanding. So let me just paraphrase and explain what he's wanting to know. He wants to know about the Iceberg connector, and he's saying it's still Hive-based. I think that's not correct. It's a standalone connector. It just happens to also understand the Thrift protocol and the Hive Metastore URL. Is that correct?
So there are some things that are shared between the Hive connector and the Iceberg connector. I think that that's decreasing over time, but like the version of Parquet that's used is, I think, coordinated. I'm actually not the expert here.
Yeah, okay, so all right, fair enough. I guess it's kind of an implementation detail. Yeah, the Parquet reader and the org reader are definitely probably going to be used by both of them, because that makes sense. We also have other connectors like the Delta Lake connector and like others where those files are read and they're all using the same readers, because, like, for example, recently we've done a lot of performance improvements on the Parquet reader, and that affects all the connectors that use that, which is great, right? So okay, fair enough. Then it sort of does, but not doesn't.
One thing I should also mention is that I don't think that there is. I mentioned support for pluggable metastores, and I don't think that that's the case just yet. I think Trino may only support a Hive metastore, because that was one of the earliest ones. Iceberg has since we contributed the Trino support, the Trino connector, Iceberg has introduced its own catalog API that allows you to do that pluggable metastore thing that I was talking about. And I think we still need to update Trino so that it can take advantage of whatever Metastore you choose to use. So it may be that the commenter is talking about that.
Yeah, Srini was exactly asking. I was just going to lead on to that, but you like preemptively read my and his mind. That's a Jedi trick you just pulled there. Very nice. So yeah, so hopefully we can work together on that soon, and maybe Srinivas even wants to chime in and help us with that on some pull requests to introduce support for multiple Metastores. Now, I think we need to jump over to another question that Srinivas had very much in the beginning, and I don't want to let him down. And that was, he was giving a big +1 to your table-to-table streaming use case. And I think that's also interesting for other people, because we hear a lot about people using Kafka and streaming use cases. So how about you jump into that a little bit?
Yeah, so this one I think is really interesting. Our streaming team brought this to us. They were the ones that built our initial like Kafka to Flink, Kafka through Flink to Iceberg connector, which is open in the open source. It does a really fantastic job of exactly once semantics and writes and all that. And it's really kind of cool because you can use Flink SQL to go from Kafka, transform your data, and then straight into an Iceberg table. So we've been using that for quite a while, and it's great. The thing that I was surprised by was that we had streaming use cases, and like our Flink team came to us and said, hey, we want to support reading from Iceberg tables into a Flink streaming application and then writing out to another Iceberg table. And we were like, well, wouldn't you use Kafka for that use case? That seems to make a lot of sense to us. But there are some subtleties here that I didn't quite appreciate in the beginning that make it actually a really attractive option. So first of all, like I actually don't know much about the Trino connector to Kafka, but if you do want to see that data as it's flowing, it's slightly different, I'm guessing, if you're going and querying it directly from Kafka. And so if you want more of the same experience across tables, I think it does make sense to look at data in between streaming jobs by querying it as a table, because you get this nice snapshot capability, so when something was added to the table, and you can see it changing as you would just a normal table.
Yeah, I can jump in there for a second. So the Kafka connector literally looks at the stream. So if you run a query and whatever is in the stream now, and then you wait 10 minutes and you run the query again, if the data changed or whatever changed in the stream, that same query will return different data, because the stream contains different data. So it's really useful for inspecting what's in the stream. If you want to do more in terms of taking that stream and doing something with it, you need to, on your own system, keep track of what did you see last, and make sure you query often enough and don't duplicate things you already saw. Or there's kind of things the connector does not take care of that. So maybe that's where that comes from, and that makes sense.
Well, yeah, so I'm just saying you have more concerns if you're reading a Kafka stream directly. I mean, there are some logging use cases that I should talk about that are really awesome if you're doing a join of what's in the stream and what's in your table. But we'll set that aside for now. So that was one thing. You can just use an Iceberg connector and get access to data in between your streaming jobs. The other thing, though, is that they said, Kafka, at least our Kafka, has a retention of maybe 6 to 8 hours, and the trouble with, writing and maintaining streaming jobs on top of this 6 to 8 hour window is that if you get paged at midnight, you have until 6 a.m. to fix it. Right?
That doesn't work well for me.
No, that actually was such a huge operational burden on people that it's preventing them from using streaming applications. Another thing, if you think about it that way, is like backfilling. So say you're fixing something at 4 a.m., you're trying to blink and keep your eyes open and drink enough coffee, and you make a mistake, you commit it, you think it's good, and data flows for another 8 hours before you realize something went wrong. In that case, how do you go back and correct your mistake? If it's been more than 6 hours since you found out that you made a mistake, then you've probably lost the source data. So having a table where you're not keeping data in a runtime Kafka system, with all of the expense there of basically having these compute resources spun up and managing the data, you can store your intermediate data in S3, which extends that retention from like 6 to 8 hours to something more like, I don't know, 7 days. What do you want to do? Like, I think it's an extra 30 cents in S3. So, you can basically extend that so that you have like a multi-day window quite easily, and for basically the same cost. That multi-day window allows you to do things like backfill the data through your streaming application a whole lot more easily, as well as just pause your streaming application for longer than 6 hours. So
yeah, things don't become time critical anymore. So it like lets off everyone on the team a bit, right, to just get things done right, I guess.
Yeah, exactly. So even just for the very, very simple append use case, it's pretty attractive to do that, because you can get longer periods of time, really good access to the intermediate data tables. It just operationally really, really helps. So I was surprised at that, because we built Iceberg as primarily a replacement for Hive tables, so we were thinking very much in terms of batch. But a lot of what we've built lends itself very nicely to streaming, because you get IDs for every single version of the table. You can quickly figure out what changed between versions, and then you can process just those incremental changes. So it lends itself very, very well to streaming applications.
Okay, so that leads me to a question that Corey asked, and is kind of related. And he's specifically asking, when you're doing the leads, what do you do afterwards? Like, do you like trigger compaction separately afterwards and stuff? And I guess that also would apply to that use case where you have these tables from streaming that sit around. At some stage, you're going to clean up. So can you maybe tell us a bit more about like regular maintenance you need to do in terms of like what happens automatically, and maybe what do you need to do on top of that because of specific use cases?
So I should mention that there is a maintenance page on Apache, or iceberg.apache.org, which is a real good thing to check out if you're just wondering about regular table maintenance. So each version is going to produce a new snapshot, and the main thing is that those snapshots exist in parallel. That gives you a window of time you can time travel. So if you keep 7 days worth of snapshots, you can time travel back to any version in 7 days. On the other hand, if you forget to age off your snapshots, you're probably keeping all of the data that's ever flown through, flowed through the table, and that's not a great thing to do. So there are a few different things that I think there are stored procedures in both Spark and Trino for expiring snapshots. And you say something like, expire snapshots older than 7 days. That will clean up the metadata and also go and delete all of the files that are no longer referenced. So when you're deleting data, usually what you would do for a streaming table, say you keep 3 days of data in this table, you have like a daily process that goes and deletes and runs like a delete from table where timestamp is less than the start of today. So that logically deletes all the data.
So does that also apply, like, so we were talking earlier about the GDPR use case where you're deleting all the data for a customer, or like whoever requested the right to be forgotten deletion. When that comes in, that data is like distributed across various tables, right? So do you have some sort of like standard we are compacting or whatever these tables every 2 weeks, we're doing it anyway or something? Or do you like explicitly go out and manage them actively?
What we're doing currently is we've implemented deletes as copy on write deletes. So there are three basic types of deletes in Iceberg. Number one is you can remove whole data files. So you can think of this as like dropping partitions. So your delete from aligns with your partitioning. We can say, hey, we could just drop all these data files. We don't need to figure out what's in them, right? The second flavor of delete is when you have certain rows, but not complete data files that you want to remove. So in this case, you say you are deleting by hour, but you've partitioned your table by day. You're going to have some files that span that hour boundary, and you're going to have to rewrite those files. What we've released in 0.11 is the way to do that in Spark, where it'll figure out which files have content to delete. It'll rewrite those data files and swap the old data files that had the deleted data for the new data files. And basically that looks like delete these files, add these files, and the deleted files will age off when you age out that snapshot. So yeah, they're just unreferenced data files. The third option for deleting is actually like Delta support that we're still working on. The spec is finished, but we're building out support for actually doing the compaction and things like you're talking about. That is, an open question of when you choose to delete those things. So the nice thing about sorry, let me go one more minute into the delete format. So basically, this option is distinguished from the second option in that we don't delete or rewrite data files. We keep the data files with all of the original rows, but we encode deletes against those rows that say, this data file row 3 is deleted, and row 7 is deleted, and row 9 is deleted. And so like you've got these deltas that apply when you're reading the data. So if you're doing those delta-based deletes, then it really depends, because you're putting off work, right? You could have rewritten that data file immediately and physically gotten rid of it, waited for that data file to be physically deleted after the snapshot ages off. But overall, like you're doing that work of rewriting the data file immediately. With the deltas, you're putting off that work. And so you have a choice of when to do the work of rewriting the data file. If you have a constraint like GDPR and your constraint says, make
like
sure all of the deltas are applied, physically applied within 3 days, then you are going to need to rewrite that data file within 3 days. But you have the time to accumulate more deletes against that data file before you rewrite it. You also have the ability to not take so long to delete things. So you can delete logically, and then even if you immediately turn around and try and commit that delete, there's not a user waiting on that to happen, right? You're guaranteed that you've deleted that row and it's gone, and then we just have to clean up some table details after that. So there's a lot more flexibility if you're using the deltas.
Yeah. All right. So that's quite amazing and makes things complicated, but these rules come in place for a reason, so it's all good.
Yeah, and what it's probably going to look like, I think Trino, you guys are probably adding support sometime soon for these row-based deletes, the Delta files. I know there's a lot of interest, and we've been talking to you guys about it. What that'll probably look like is, turning that on for a table, and then having another stored procedure that says, okay, go compact go compact this portion of the table, or something like that, in order to ensure that those physical deletes actually happen. We're planning on building a service that does this, that looks at the table and says, what policy do I need to apply? If this is a log table from our own internal applications, we're not going to apply those deletes within a day. We're going to do something like, how many times do we think we're going to read this file in the next week? If that's a lot, then maybe we should rewrite it, if there are a lot of deltas. If we never expect to read the data file again, why would we compact it and rewrite it? On the other hand, if it is like a customer table, you know, gonna rewrite it within whatever time period we have. I honestly don't know.
Yeah, Corey has a related question, and that is, he's asking, how do you avoid large list object scans on AWS due to the rescanning, and how do you avoid compacting files that are already compacted?
Okay. So I'll take at least the first question, because that's easy. Iceberg doesn't list anything on AWS. There is no listing calls in Iceberg with metadata tables, Metastore tables. That was one of the things that was just unreliable for the longest time. Sorry, not unreliable, eventually consistent. So it made your tables unreliable. And one of the things that we wanted to do was avoid the really expensive and error-prone operations. So those are rename and list. So like those are really expensive in HDFS, and they're also super expensive or unreliable in S3. And so we avoided all of those. That's actually one of the biggest challenges with the Hive table format, is that you're using those operations. So that's an easy one. What was the second question?
The second one was, how do you avoid compacting already compacted files? My guess would be that you're leaving a timestamp behind when it was last compacted and when it was last written to, as a minimum thing, but I'm just totally guessing here.
Right, so it depends on the type of compaction that you're doing. If we're talking about just compacting data to make larger files, we have a filter that basically goes and says, okay, well, I'm going to compact anything that is outside of this range. And that's like 20% below your target size or 10% above your target size. And then we're going to rewrite all the remaining files. And so if you're achieving your target size, which is kind of a big if, right? And that's where the min and max really matter. I think it might be even 30% below the target. You know, if you're achieving your target size, you're not going to recompact those files, except maybe the last little bit that is too small to form a whole file. On the other hand, if you're talking about deltas, that is a more interesting problem. In order for deltas to actually work, you're right, we need to keep track of when things happened in the data set. Because I could have, you know, write row ID equals 5, delete row ID equals 5, and insert row ID equals 5. And I need to be able to keep track that the initial copy was deleted, the new copy is still live. And to do that, we introduced sequence numbers in our metadata. So the sequence number basically says when something happened in time. And so when we're applying deltas, we only apply deltas to data files with an older sequence number. When we rewrite, we rewrite with a new sequence number or an updated sequence number. And so the delta is no longer applied, and we basically know that there are no deltas against this file, so why would I compact the deltas?
Yeah. So it falls through a new op, basically. That's cool. Yeah.
And that was actually kind of a difficult thing to do, because we wanted to not rewrite a ton of metadata in the table, which might be a fun topic for a future meetup, if you guys care. That's in the weeds, though.
Yeah, we're always ready for another meetup. That reminds me, we are closing in on time, pretty much have to wrap up soon. So let's see. There is one question about how to contact everyone. We'll take that at the end. There was a question from Siddharth that we already kind of covered, and he was like asking about if you have data in Iceberg and in Hive and you want to query it in Trino, is there some magic way that users automatically query the right one, sort of like an intermediate knowing which table is where thing? and that does not exist. You could put something on top that handles that by sort of adding like a proxy in front of it, but nothing out of the box exists in Trino at this stage that I'm aware of.
I would also recommend not keeping copies, 2 copies of your data like that. That's a tough thing to keep organized. I would say you probably want to switch your Hive table over to Iceberg by importing or migrating the table. Again, it's just a process of building Iceberg metadata for that table and then referencing the new table.
Yeah, Siddharth specifically is talking about federated queries where you want to access Hive and Iceberg, but you don't want to rely on the user having to know where it is. And yeah, maybe the best thing is to migrate, obviously, but to Iceberg. But of course, that gets tricky when you have lots of data and stuff involved.
Like I said, that's something that we implemented internally to Netflix, and we kind of hacked it into Trino. I would love for there to be a better way to do that, but it just doesn't exist yet.
Yeah, we'll get there, I'm sure. So another question, quick from Bill, was when are row level deletes finally special? Like when is the spec going to be finished for that? Are you working on that? Or is
we are working. That's like my top priority. The row level delete spec is so the actual row level deletes were pretty much solid. They're implemented in Iceberg 0.11 for people to start building on top of. And now we're building like compaction and some of the I believe are pretty much done. The only one that we need to do is add encryption key metadata to the manifest files. So once that's done, we should be good to go finalizing it, hopefully in the next couple weeks.
Awesome. Well, it looks like there's a lot happening. So I think we should sort of round out. So as a last thing, where can people find you, Ryan? Where can they ask questions about Iceberg and things that we talked about today, apart from the Trino Summit maybe in the future, or if you're attending or someone else? What tips can you get people where to go to learn more?
Yeah, I'd be happy to talk at the Trino Summit. I should talk to you guys about that.
Consider yourself booked.
The best place to go is the Iceberg dev list or the Iceberg channel on the ASF Slack. Those are the 2 places where people tend to congregate. We're thinking about starting an Iceberg Slack community that is easier to join than the ASF's Slack community, but we haven't done that yet. There's also the GitHub page, so github.com/apache/iceberg. That's what we use for all issues and pull requests and things like that. So any one of those 3 places is a great way to reach out.
Excellent. And just to clarify, the ASF Slack, that's literally the-ASF Slack, and it's the Slack instance for the Apache Software Foundation in general, where all the Apache committers only have access, I think.
You can be added, but you have to request access. Yeah. So it's unfortunate.
Yeah, not to worry. I'm sure the pressure will amount. And that gets me also to our reach out. So make sure to ask any Trino related questions also related to Iceberg and the Trino Slack. So Trino.io is where you can find all the information about the upcoming events, the Trino community broadcast I run with Brian, and anything else related to the documentation. And there's also various channels. I can fire it up here quickly, in fact. And you can see we have channels for all sorts of things here in the Trino community Trino Slack about Iceberg specifically. There's one channel that's specifically dedicated to Iceberg, and you can definitely ask your Iceberg questions here. But then there's lots of others where Trino community broadcast and others are available. So with that, I think that rounds out our meetup today. And I would like to say thank you everyone for joining us. And I'll see you in the Trino Community Summit, the Trino Community Broadcast, or on Slack.
Thanks for talking with me.
Yeah, thanks, Ryan. Bye, everyone.